And now it's time for our ladies. Our first lady today on the main stage is Kim van Wilgen. Kim is an experienced leader in software product development. She's passionate about topics such as DevOps, continuous delivery, Agile, and continuous security. She's a speaker at national and international conferences on topics such as Agile and continuous delivery, and she's here with us today to talk about continuous security. Welcome, Kim.
Okay, so I'm hoping it's the right setting. I'm not sure. Let's just start. Okay, so I would love to talk to you about continuous security. And for me, that has been a journey on how to move to DevSecOps. And that's a word that I hear people use a lot, but I also feel that we're only making the baby steps into what that exactly is. So I think in 2016 was my first encounter with this, because we were in a situation where we thought, okay, now we have DevOps and we have a lot of responsibilities within the team, and we want these teams to be able to move forward autonomously. But if we really want this autonomy in the team, then there should be a certain responsibility towards security in the team. And what I found is that we actually knew very little about security. So that people were always kind of helped by some central team, and that the information that they needed to actually take up this responsibility was not yet really within the team. So we tried to change that and try to move ahead, and I would like to take you along. So first of all, Equifax. Equifax is a bank, and they have, of course, payments. In September 2017, cyber criminals accessed the personal data of 145 million customers. That's a lot. And 209,000 euros in credit card of 209,000 in amount of credit card credentials were taken from people. So they could do a lot of damage with that. 300 million ultimately was paid to victims, and 275 million was paid in fines. And that seems like an extreme amount, taking 209,000 credit card details of your customers. What we actually did is we looked at this attack, and it was not some kind of screw up. It was really an open invitation. If you look at what happened, there was a forced browser opportunity to actually go beyond the UI and directly go into the APIs and access this data. But that was not the only thing. There was also admin was the username and password for the admin account. When they used Apache as a tool in their services, there was a vulnerability, and it was registered in March 2017, and they left this vulnerability until September 2017 until somebody exploited it. They did not fix this vulnerability, but they could have known this one. And when they found out this wasn't a screw up, they started sending out tweets even with links to phishing sites. And that was pretty horrible. But is this a one-time item? Well, actually it isn't. I was in Sri Lanka, as already stated. I love traveling, and there was this little rock that you could climb. And these days there were these nice little stairs, which were pretty safe, or at least reasonably safe. But you could also see the old road, the old stairs that the people used, and these are carved out of rock. You see them at the left side. And if you would walk there, every nerve inside you would say, be very careful. If I make one little mistake, I'm dead. And that's what fear does. Fear protects us. But we don't have our nerves to keep us safe in software development. So in software development, nobody ever experiences fear. It's not like you're climbing a rock and that you feel, if I screw up here, I'm dead. So it's very a rational feeling of fear. We have to think about the things that can go wrong, and it's not our main focus. So I think this tweet really puts it out well. Software culture really does not understand prevention. They do not understand looking at a situation and thinking, well, what can go wrong here? Because everybody is focused on new features, because that's where everybody is pushing for. So we also not always have time to even reflect on the security issues we are putting into our applications. So when our nerves are not keeping us safe, we have to make that up by different ways, because it's not our bodies that's protecting us. And actually, the face of security is changing. So you could wonder, why did things not go wrong so badly as with Equifax? Also in the last 50 years of software development, there's actually quite little very big hacks known. But I think personally that the face of security is changing. And I would like to take you along in that. So first of all, focus shifted to speed and actually nothing else. So as I just said, you're working on pushing out features because your competitor's doing this at a speed that's increasing and increasing, and you have to keep up. And that's pretty hard in itself. And if you're only focusing on speed, well, maybe you're missing out somewhere else. We also moved to a world of constant change. So where we used to have 1 or 2 times per year deployments, we now have deployments every day, multiple times per day, or at least every week, depending on the company you're working with. And in a world of constant change, it's much harder to, if you have this once in a half year release, you can do a pen test, and you can do a very focused moment to look at the security setting of your application. And you cannot anymore, because you cannot check, you cannot perform a pen test every day or 30 times per day, if that's your pace of releasing. I think Alex Burson, he found this really big screw up in PayPal, and he also collected a bounty for it. You're bound to find something new, especially if the code you are testing has been in continuous development for a while. The example of the thing he found in PayPal was something they added after the first release, obviously, because we are continuously improving our applications. So what was added was a check, I'm not a robot, because they were experiencing DDoS attacks. And with that check, I'm not a robot, you could actually circumvent the whole password policy in effect. So that was something that was added later, and the impact on security was not really assessed at that moment. So this is a situation we are often in. We initially think very well about security, but as our applications change, we introduce vulnerabilities in it, and we do not have the time to stand still and check them. Another risk is everything is now connected into the heart of your business. So where applications used to be this little layer on top, and your business will be well protected with probably a mainframe that was inaccessible, or even without automation, with users manually acting. Now every process is fully automated, or at least automation is a significant part of it. And that means that the risk and the impact of a security flaw is way bigger. And we are moving to the open API economy. So there's doors everywhere in our applications. They are also designed to have these doors. But now the protection of these doors is way harder. If there's just one door, you can protect it pretty well. If you have doors everywhere, it's much harder. Also, in this case, Postel's law is very important, where we are very liberal in what we accept. So we hardly have any breaking changes anymore in our APIs. So that means that somebody who extends an API with an additional piece of data, which may be a very privacy sensitive piece of data, all the applications that are using this API will not break. So it might be that you're exposing data to a place that was not designed to have this data, and nothing will break. Everything will keep on working. Are you actually sure that when you add a piece of data, that you're not exposing it somewhere to a client where it should not be? And I think that the visibility of this is very limited in our current architectures. We're moving to autonomous teams. So our teams are all self-steering, but that means that we are lacking a central capability of security that will keep us safe. And everybody is changing roles, and this is pretty uncomfortable. So we're asking all the people to be T-shaped, to take responsibility as a team, and to step into things that are probably pretty alien for them. If you're doing something that's new to you, you're bound to make mistakes. And then there's this CICD chainsaw massacre. So we're introducing pipelines to speed up in our releases and to also make them less painful. But these CICD pipelines introduce a whole new center of vulnerabilities, because if you would hack into these pipelines, you have control basically of the mission control room. Once you gain control of the pipeline, you control everything. You can do any commit that you want. And we did not learn yet properly how to protect these things. Another thing is that we now do releases without deployments. So we're using feature toggles, and that putting the toggle on while we are in production is, so dark launching your features is a very common practice these days. But are you also aware that this code, once the toggle is off, is out of reach in pen testing and scanning? So are you also asking your pen testers to test everything with the toggle on? Because it might be that you're exposing something in a release without even knowing it. And we are trusting ourselves a lot with security tuning. So we think that this central gate will keep us safe, but we do not learn how to look at the setting around it. And we also do not really comprehend what the security tooling does and does not do in keeping us safe. So we think, well, we have this tool running, we don't have to think about security anymore, but you do. So basically, this is a very quick, hopefully fearful summary to say, if you're doing DevOps without security, you are doing it wrong. This is a remark that Thiago Faria from AWS said, and I completely agree. If security is not an intrinsic part of your DevOps, it's wrong, it's broken. So how to do better? How to do security in an agile world? Well, first of all, this is something I would definitely hate, but it is something that I do see a lot. Security kind of keeping or blocking every piece that a team does want to push forward. So a team is working very hard to actually deliver a lot of features, and then the security person says no, no, no. And that's not the way it should be, because actually we have this same goal. We want our business to thrive, and we want to push forward on these new features. So security and the DevOps team should actually work together to make that happen, because it's in nobody's benefit to start saying no, no, no. But this is also not how it should be. It should not be that the DevOps teams just, well, basically pushes out shit, and that the SEC team is there to clean it up, because that's not the kind thing to do for your colleagues. We actually want a shared ownership, but we also want security as an enabler for functionality and not as a blocker for functionality. And that's why I developed a model to actually make that happen. It contains defensible development, defensible infrastructure, a supporting way of working, and education and awareness. But first, something about me. So I'm Kim van Wilgen. I'm from Holland, well, already said, I love to travel. I have a boyfriend. He will do the opening keynote tomorrow. He's Sander. And together we have 5 kids, so we're really busy. I love board games. In my professional life, I love leadership. I hate management, so I moved to a company that has no managers, and it's fully self-steering and self-organizing. I love coding. I always want to be on an innovative barrier, and I also obviously like speaking, so here I am. And the company Schuberg Philis, what I love about it is it has one KPI, and that's 100% satisfaction. So we do everything that we can to do the things the way we actually would want to do them for this customer, to make sure that, well, it's basically the best the customer can get. So we're an outsourcing company. It's about the people, actually. That's our narrative. So we try to make the people matter. That's being said, I won't hold back anymore. So defensible development. This is about coding. Well, there's one thing that you have to remember from this talk. If you want to do DevSecOps, automate, automate, automate. If you want to release 30, 300, 3,000 times per day, or even once per week, you cannot do these checks by hand. So make sure that you start your journey in automation. That's also what makes it fun, because security can be pretty boring, but it won't be once you are starting automating it, because automating security is actually pretty challenging, pretty exciting, and also about engineering and coding, which we love. So all's good there. And how to do that? Well, somehow I feel this is the part that we did not get educated. So if you have a pipeline, you can integrate a lot of security tooling in this. And the security tooling is out there. It's just simply not so well known. So this is, for instance, how our pipeline works. And as you can see, this is a security test. It runs for 44 seconds. That's something you can do 30 times per day. And then our security checks run, and these run for 4 minutes. And that's also something you can do 30 times per day. So what kind of things can you do to keep your code safe? Well, first of all, there are static analysis security testing. So we all know static analysis, mostly for quality issues, and quality is a very important factor in security, by the way. But there's also a specific test on the static analysis layer to check security. It means that you're inspecting your source code for known unsafe structures. And tooling will scan this, and probably there's a lot of tooling that works within your IDE. So it will show you at the minute you write a piece of code, it will show you, well, you are introducing a certain vulnerability here. And it will also make suggestions, if you choose a good tool, how to do better. So a known good code structure that actually is safe in comparison to the code you have just written. So what's wonderful about this tooling is it's immediate feedback. It's very precise feedback. So you know where the problems are in the life cycle. It's very scalable because every developer gets this individually. You don't have to wait for a build. So these are all very nice things. There's also some downsides. You get mostly a lot of false positives. So you have to make sure that the rule set that you're using is improved and improved until it really fits your context and your needs. So don't just use the default rule set, but make sure you adapt this. An example of such a tool is SonarQube, which we probably all know in terms of static analysis. It actually has a module to do security testing, but you do have to install it. It doesn't come there out of the box. If you want to compare them, the OWASP organization actually has a comparison. So you can see what tools, what prices, and also how many false positives and false negatives do they have. Next layer of security is dynamic application security testing. And these tests, well, they basically are an automated pen test. So they test the application at runtime. It's a very realistic view. You get very little false positives. So once you get a vulnerability here, it's there, it's real, but it's a bit harder to track. So if there is a vulnerability, you have to investigate where did this come from. So that costs you a little bit more time, and it needs a running instance. So that means that feedback is delayed until the moment that you build your code. So that's why it's good to combine these tools to make sure that your code is safe on the static layer, but also on the dynamic layer. Some examples that we use are X-Ray, Nessus, Sentinel, and Zep. But there's a bunch more. Again, there's a link. So investigate this and make sure that you add that to your pipelines. And then you have to make sure that you check your libraries if they're not broken, like the one in the picture. So you have to do dependency checking. And dependency checking does not run in the pipeline. I think that's the most common mistake that's out there, because dependencies are, of course, external. So these can get vulnerabilities also without you changing the application, probably without you changing the application. When you use an external library or a framework and somebody finds a vulnerability, they will mention this vulnerability in the central vulnerability database, so it will get a CVE notice. The dependency checking tool actually compares your libraries with these CVE notices and will notify you when you have a library in use that actually has such a vulnerability. And tooling is very different in the precision in which they inspect your library. So it may be that you have a library where you only use one module, and that in a totally different module there is a vulnerability. You don't want that one notified, because then you will be updating your libraries all day long, basically. So make sure that you get one that is specific enough, that actually checks that you are using this specific piece of the library where the vulnerability is mentioned. Examples of that one is the OWASP dependency checker, JFrog X-ray, white source bold, and Sonatype. For instance, for white source bold, it will also, once you are looking at a library, already state what vulnerabilities are there and how reliable the library is. So it will also help you at design time already selecting libraries that are known to be safe. So definitely make sure that you do this. And there's one thing I would like to also point out, that's RenovateBot, and that is a tool that will automatically build your libraries and set forth a pull request, so that you only have to check the pull request and everything else is done automatically every time that a library has a new version, so that you can keep up with pace, basically. Then in automation, also make sure that you inspect your code. And a very simple thing to do there is peer reviews. So what are you actually looking at in a peer review? Are you also looking at the inherent safety of a solution? Make sure that you include that in the inspection of your own code, because that's the moment where you can actually stop and smell the roses. There's also a tool called SAML, and there's a bunch of tools similar to this one, and these do variant analysis. And basically what it is when you have a dependency checker, it will check, of course, the vulnerabilities in libraries. And what the variant analysis does, it seeks similar patterns to known vulnerabilities in libraries. So when this tool sees that in a library a certain thing was unsafe, it will look at the same pattern in your code based on a little bit of machine learning and say, well, that was unsafe in that library, so it may also be that it's unsafe in your own code. So this is a very nice innovation that you can use in your benefit. SAML has become part of GitHub, so it probably will integrate very well if you're using this. And then the last thing is the evil user stories. So you can also add some custom scripting. If there is a layer of security that's very important to your business, and if it would not be there, you would be compromised, then it's good to also always monitor and check that this layer of security is functional. So for instance, a whitelist on IP addresses is very common. So it may be that you add a custom script that says, well, as a malicious hacker, I want to gain access from any IP address to all repositories, so that I can look for vulnerabilities and secrets and destroy their entire business. Basically, it checks, can I access this resource or this repository from an IP address that's not whitelisted? And this test will become red when that's possible. In this way, you can always check that this layer of security is up and functional. It's not expensive to make, and it adds a lot of safety. So that was defensible development. And then we move to defensible infrastructure, because the code has to be safe, but the infrastructure also. Infrastructures are historically very safe. It was always where at least 80% of security was implemented. So I'm not going to tell you how to do that, because that's a very broad topic. I'm definitely not the biggest expert on that. But what I do want to take you along in is that the infrastructure has also moved to become more agile. So there's a lot of changes in infrastructure. And did we also really think about the changes in our security setup that are the result of these movements in infrastructure? So first of all, there's the immutable infrastructure mindset. So we see a lot of movement towards immutable infrastructures, where where infrastructure is moved to code and where you deploy that and where you cannot change the infrastructure on production. It's immutable. What you can do then is actually scan the infrastructural scripts, because now infrastructure is code. So you can also security test these code structures. Make sure that configuration changes and patches are also handled as code changes, that they follow the pipeline and that tests are being executed on this, to make sure that you do not introduce security flaws directly in production without testing them. So make sure that you do use your layers of security there. If your infrastructure is immutable, you don't need an admin account on your production instance anymore, if you're able to push it out to production fast enough. So apply least privilege principles. Make sure that you actually cannot do anything with it. And also apply pervasive visibility. So make sure that you measure everything that's happening with your infrastructure. What's also really cool is if you are pretty advanced on immutable infrastructures, you can start automatically rebuilding your infrastructural components, so that if a hacker would gain access to one component and it would automatically rotate its instances, it would be very hard to survive as a hacker having access to these components. So that's something that you can start doing. If you're testing the infrastructure, there are certain tools for this also. So you can automate these new ways of bringing forth infrastructures. One tool that we use is Chef Inspec. It tests the hardening of your system against the CIS best practices. So it will basically tell you you have known unsafe infrastructural setups. And there's, for instance, Twistcock, and there's Notary and New Relic. And the AWS security services. And these are specific security scans designed to test your Docker instances, your Kubernetes clusters, your Java virtual machines. Again, it's mostly the unknown of these things. It's not hard to set them up. If you're using Docker, you might be introducing security things. Look at this tool and see if it is beneficial for you to start using it. Then the supporting way of working. Because yes, we can automate a lot, but it's still about people actually. So it's still about people understanding security enough. It's good to have security champions. It's good to have some people who are really experts in security. We can transfer a lot of security knowledge to the team, but it's good that somebody is really giving it some tender loving care, and that he or she has really the expertise in depth to lead the team and to guide and coach the team. So what we do is we have a security lead in every team, and there's a central security team with the really in-depth knowledge. The security lead leads the team journey towards security, but if he or she has a little bit of knowledge not already at heart, he or she can reach out to the central security team for some consulting and coaching on that. So that's a way to actually grow your security knowledge in your organization. Be sure to coach people to not eliminate all risk, because having an application that's really secure means probably that it's unusable and inaccessible for all people. So it's about the balance between business value and security. And that's also in here. This is actually Chinese toilets. And these are very safe in terms of what's happening in the toilet. But it's also not really addressing privacy or business value anymore. People really love closed toilets. So make sure that if you start improving on your security journey, don't go too far. It's about the balance. Learn and adapt first before you start breaking the build. So if you start introducing these tools that I just mentioned in your pipeline, make sure that it's possible to circumvent them. Because if you start breaking the build and people are not able to push out any code anymore, then probably people start hating security very fast. So make sure that it is more a guideline, at least at the start, that you say, well, you might look at these things if you have some time and some headspace for that. And start helping people. Don't start blocking people. You don't want to be that person that blocks every piece of functionality that you want to push out. know your risks and act early. So what we also see is that there are early warnings. There are some lower incidents that are actually the early warnings of bigger incidents. Make sure that you actually look at these warnings, these smaller incidents, and that you have time to think, okay, so what is the bigger thing behind this? Because that's what's preventing one of the bigger screw-ups. This is also really important. Fix your vulnerabilities. So once you start scanning with automated tooling, it's very common that nobody actually takes time to fix them. Scanning doesn't make you any safer. Documentation doesn't make you any safer. A policy doesn't make you any safer. Changing your code, changing your infrastructure, actually changing the software itself, that's what makes you safer. So make sure that people actually fix these things. And identify and remove and start small. So for instance, for such a SaaS tooling where you can inspect your code on the static level, you can start with a rule set with thousands of rules. And probably people will start hating it very fast. Because now they're thrown with thousands of errors on every commit. So people start ignoring it. Make sure that you start with only a small rule set, maybe even 10 rules, so that people start understanding what they can do better. Don't throw a tsunami over them. Make sure that you sit beside them and that you coach them, like, okay, why is it giving this warning and how can you actually do better? Because then you will grow in understanding, you will grow in knowledge in your team. And the last thing is education and awareness. So there are security bugs, and these are things that you can automatically check and that you can scan against in all the ways I just mentioned. But there's also security flaws, and these are more logical errors. These are things that you cannot scan against because the gate is okay. It's just that, for instance, there's no walls beside the gate, so you can simply walk around it. That's a security flaw. It's something where the setup simply does not add up. So make sure that there's also always time to actually talk and think about it. And how can you do that? Well, train for the basics. Make sure that people understand, for instance, what a proper password policy is. And educate on automation. So it's how do you deal with false positives? How can you actually change these rule sets? What's the process for changing these rule sets? Make sure that you teach people on how to code safely. Make sure that tools are available in your organization, that people don't have to go through the process of selecting them, comparing them, even getting a license for it, getting the budget for it. Make sure that people are helped in this journey. And create also contextual awareness. So this is an example of a company that thought it was a good idea to start selling drugs through an application, through an app on your phone. I think now Netflix even has a series, How to Sell Drugs Online Fast. I'm watching it with my son. So it's kind of this story. Once you start doing something like that, you have to make sure that you are doing something really secure. It's the context that makes everything. What this individual company did, they thought it would be a great idea if people would upload their passport to make sure that if something would be happening, that they could identify and find this person. Of course, the police also found it very interesting that people would upload their passports. So what happened is they watched this app for about 9 months from the police, and after 9 months they imprisoned everybody who was dealing drugs. So the message from this is some things you really should not do design time. Don't do things that are so inherently safe or that have such a big risk in itself that they are too big of a honeypot. Make sure that you keep away from things that are too attractive for hackers. And that's something you can do design time. So for instance, in this application, it would have been much better not to upload passports because it's just too unsafe. that's also what we're doing, security upfront. So once we start using a library or we start using a SaaS service, we always upfront check against a list of criteria. It's not a lot of work. It's 10 minutes, just this moment that you stop and think about, okay, is this a service that I can use, or am I introducing something here that I do not want to make up at the end? I also want to not even start this journey. So this is in effect a way of doing security by design. What we also did is we started hacking ourselves. So we all know chaos engineering, where we make rare events regular. And security hacks somehow are still quite rare. So that means that we're not really aware of all the insecurities that we are introducing. And if you are inspired by chaos engineering, you can do chaos security engineering. You can make sure that a hack is something that happens very commonly. How did we do that? Well, once a month we had pizza sessions where we started trying to hack the applications of the other teams. People would learn on the one hand a lot about how a hacker thinks, because thinking as an attacker is very different from defending from an attacker. And also the teams would know, like, okay, end of the month, there's a pizza session and people are going to try and hack us. So people were much more aware of security in their journey. And it was also great fun, basically. So that's a nice way to start this journey. It's also what Troy Hunt, one of the most important people in security, says. Thinking as an offender will show you the real threats of your application and grow awareness from finding out how easy it is. So once you really start learning how a hacker works, that's the moment when you can properly defend against it. So in the end, it's all about the mindset. There's also red teaming, and that is a form of social engineering, where you can say, well, there's a red and a blue team. And the red team will try to use every way possible to get into the building, get into the system. And I think we, from our company, are very proud. We had a red teaming session and we were unhackable. Everybody who was unhackable would receive a cake, and that's on the picture. And for me, the most inspirational thing in how you can grow this mindset is that the minute after this picture was posted, one of the engineers said, well, did you check the cake for hard and sharp objects before bringing it inside? And that's security awareness. That's the moment when you know it's everywhere, because in the end, it's about the people. If they have this security mindset, that's when you are safe. That's it. Thank you for your attention.